Hello everyone, this is not for electrical engineering, this is for electronics engineering. So it is for electronics engineering. And this is lecture number 1. Okay, so we are going to discuss today. I am going to teach transmission line theory in this class. So in 10 to 12 lectures I am going to teach you transmission line theory, and in transmission line theory I am going to teach you the question discussion as well as derivation and something more part. Okay, so there is no recap. Actually we have just started the class, so there is no recap. Today I will discuss basic of transmission line, Second, I will discuss basic parameter of transmission line. This is transmission line crash course. Okay, it is not full course, it is crash course. That means I am not going to derive anything, just I am going to give you brief and then after question discussion and something else. Okay, so I am not going to derive any equations, I am just giving you the summary of the points, summary of the lectures, and I will try to explain everything about this transmission line. But derivation is not important here, because in GATE exam they will not going to ask derivation. I will try to solve all PYQ questions of transmission line, all good questions, not all PYQ, maybe all PYQ I will solve, but I will try to solve all PYQ questions of transmission line and concept related to that. Okay, so first part is our what we are going to study, basic how transmission line is made up. So transmission line is made up of two types of material, first conductor and second dielectric. So I am going to write down that transmission line is made up of two types of material, conductor and dielectric. So first point is transmission line is made up of two types of material, first our conductor and second dielectric. So what we will do, so there are two type of losses in the transmission line. So there are two types of losses in transmission line. In transmission line there are two types of losses. First one is conductor loss. How it will be? So as we know that in electromagnetic field theory, the resistance will be the surface resistance, and in network theory there is a DC resistance. The DC resistance formula will be rho L by A, and the surface resistance formula will be under root omega mu upon 2 sigma C. So at high frequency, surface resistance or AC resistance will be present, and at low frequency, that means in network theory, the DC resistance will be present. So you have to analyze that according to that. So at high frequency, surface resistance or AC resistance will be present, and at low frequency, DC resistance will be present, that means rho L by A. So at high frequency we will discuss transmission line, at low frequency we will discuss network theory. In kilohertz, hertz to kilohertz, network theory, and in megahertz to gigahertz, transmission line theory. So in megahertz and gigahertz, what will happen? Surface resistance will be there. So I can say that there is a surface resistance. What is the surface resistance? Formula of surface resistance, omega mu upon 2 sigma C. This is also known as AC resistance. This is also known as AC resistance. So as we know that conductor, as we know that there is a surface resistance. Yes sir. So there is a 3 types of conductors are there. First one is perfect conductor, second one is good conductor, third one is poor conductor. So I am going to tell you everything. So we are going to discuss first conductor loss. So what is conductor loss? What is conductor loss? This is basic. They will ask the question from basic also. So what is conductor loss? So conductor loss, first of all I will take what? Perfect conductor. So perfect conductor is silver, gold, it is something like that. So perfect conductor is silver, gold, this is the perfect conductor. In case of perfect conductor, conductivity is very high, infinite, and because of that the surface resistance will be 0. Because of that the surface resistance will be 0, and surface resistance is 0, so we can say that power loss or loss will be 0, because resistance is 0, so loss will be 0. Second, thank you. Second I am going to tell you about good conductor. Good conductor is, we can say that good conductor is our brass and copper. So in case of brass and copper, sigma C is very high. Sigma C is not infinite, but it will be very high. So because of that loss resistance will be very low. So loss will be also very low, because loss will be also very low. So if we make transmission line from brass or copper, then there will be loss, but it will be very low. But if we make transmission line with silver and gold, the loss will be approximately 0. So we cannot make transmission line with silver and gold because it will be very costly. So we make transmission line with brass and copper. So there is some loss in transmission line. In interview they will ask that how you can minimize the loss in the transmission line. So you can say we can use a perfect conductor so that we can minimize the loss in the transmission line. Give me the example of perfect conductor. You can give the example of perfect conductor. Then if you want price should be very low, then you can use poor conductor, because for cheaper price you can use poor conductor. That means aluminum wire is somewhat cheaper, but copper wire is somewhat costlier. So sigma C is high, so our RS will be low and loss will be low. but it is not will be very low, so loss will be low. So you can give the question's answer according to that. So they can ask the question according to this. Okay, so this is a very good question for interview, and this is very good question for theoretical question in exam also. Good. Second or first is conductor loss, second is dielectric loss. What is dielectric loss? Dielectric loss I am going to tell you. Dielectric loss is of two types. First dielectric loss is our dielectric loss are two types. First dielectric loss is due to free electrons, and second dielectric loss is due to inertia. So I will say that there is two types of dielectric loss. First, due to free charge particles. Free charge. How it will be creating loss? I will tell you how it is creating loss. So I am taking a perfect dielectric. What I am taking? I am taking a perfect dielectric. So for perfect dielectric, what it will be? So in case of perfect dielectric, the conductivity is very low. So in case of perfect dielectric, the conductivity is very low, and conductivity is very low, so there is no loss due to conductance. So G will be sigma D epsilon upon sigma D upon C by epsilon. It will be C by epsilon. So sigma D upon epsilon into, so G will be sigma D upon epsilon into C. So if sigma D is equal to 0, G will be also equal to 0, and G is 0, then you can say that there is no loss, so loss will be 0. What is G? I will tell you later. It is conductance. So conductance will be 0, that means resistance is also 0, so there will be no loss, and there is no loss, so it will be 0. If I am using lossy dielectric, perfect dielectric or lossless dielectric, if I am using lossy dielectric, in case of lossy dielectric, sigma D is non-zero. In case of lossy dielectric, sigma D is non-zero, and sigma D is non-zero, that means conductivity of dielectric is non-zero. Sigma D is conductivity, so conductivity of dielectric is non-zero, so G is also non-zero. If G is non-zero, so you can say that G is non-zero, so loss will be also non-zero. So in case of lossy dielectric, loss will be non-zero. Then they will ask, tell me the example of perfect dielectric. So perfect dielectric example is Teflon, acrylic, any polymer, you can say that perfect dielectric. So any polymer, you can say that perfect dielectric. Okay, so this is the points here. So due to free charge, there is conductivity, and due to conductivity, there is conductance, and that will give you loss. So I am taking a dielectric. So dielectric is what? Dielectric is made up of dipoles. Dielectric is a type of insulator. In which it has dipoles. So it is a type of insulator in which it has dipoles. So if it has dipoles, then it is known as dielectric. So there is a dipoles like this, and there is somewhat free electrons also. In lossy dielectric, there is free electrons also. So in case of free electrons, what will happen? These free electrons will give the conductivity. So in case of lossless dielectric or perfect dielectric, in case of lossless dielectric it will be, so in case of lossless dielectric, free electrons is 0, there is no free electrons, free electrons is 0, free charge particle is 0, so conductivity will be 0. And in case of lossy dielectric, what will happen? In case of lossy dielectric, there is some free electrons, and that free electrons non-zero will give non-zero conductivity. So in case of lossy dielectric, free electrons is non-zero. So some material has free electrons 0, some material have free electrons non-zero. So in case of lossy dielectric, free electrons is non-zero. So I am saying that the lossy dielectric will be made up of, so lossy dielectric, there will be somewhat free electrons, and because of that free electrons, conductivity is non-zero, because of that conductance is non-zero, and because of that loss is non-zero. In case of lossless dielectric, there is no free electrons, so there is no conductivity in the dielectric, so there is no conductance in the dielectric, so there is no loss in the dielectric. Okay, next we have dielectric loss, then due to free electrons, and second one is due to inertia. So this is cannot be minimized, this cannot be minimized. So I am saying that conductor loss can be 0. Just listen carefully. Conductor loss can be 0 by taking perfect conductor. So conductor loss can be minimized. Dielectric loss due to free electron charge can be minimized by taking perfect dielectric. By taking perfect dielectric loss due to free charge, it can be minimized. Conductor loss by taking perfect conductor, it can be minimized. But dielectric loss due to inertia, it cannot be minimized. So there is one loss always present in the transmission line, that is dielectric loss due to inertia. So due to inertia, what will happen? This is our dielectric, yes sir, this is our dielectric, and this is the source we are applying. What will happen? If I will apply positive voltage, here plus, here minus, here plus, here minus, so electric field will be like this. So external electric field will be like this. So our dipoles will be oriented like this. If there is a negative voltage, the electric field will be oriented like this. So what will happen? The external noise, the dipoles will be oriented like this. So if the direction of voltage source will change, the direction of what? The direction of dipoles is also changed. So if I am taking positive voltage, it will be, dipoles will be like this. If I am taking negative voltage, it will be like this. So we know that the nature of voltage will change. This one is positive, this one is negative. So in case of this one, it will be like this. In case of this one, it will be like this. In case of this one, it will be like this. And this will this will happen again and again. If positive charge, it will be like this. Negative voltage like this, positive voltage like this, negative voltage like this, positive, negative, positive, negative, positive, negative, positive, negative. So dipole is rotating. And because of that, there is a displacement current in the transmission line. So what will happen? The dipole is rotating due to change in the nature of potential, and the nature of potential will be changed frequently. It will be changing 10 to the power 9 times in 1 second. In 1 second, the nature of potential will be, the nature of voltage will be changing. So 10 to the power 1 billion times is changing in 1 second. That means 1 billion times this rotation of dipoles occur. 1 billion times this rotation of dipoles occur, and because of this rotation of dipole there is a heat generation, and that heat generation will give you loss. So why it is giving heat generation? If I am moving like this, yes sir, I will be moving like this, yes sir, after some time I will be moving like this, I will be moving like this, I will be moving like this, and I will be moving like this. If I am moving like this, then what will happen? It will happen that the inertia will be changing, because I am moving in this direction, the inertia is in this direction. If I will come in this direction, the inertia will change. So like that, if pen is like this, yes sir, it is rotating like this, inertia is there. If it is rotated like this, inertia will be changed. So there is a change of inertia after it change in the rotation. So if change in the rotation, there is a change of inertia, and that change of inertia will gives force or loss of energy, because there is a force, there is a work, there is a loss of energy. So this is the work done by the voltage source, and there is a rotation, and that rotation, that vibration will give you the loss of energy. So there is, if frequency is increased, rotation will be increased. If rotation is increased, our loss will be increased. So power loss will be related as, due to inertia, power loss will be related as directly proportional to F square. So power loss is directly proportional to F square in inertia. If I will take 10 gigahertz frequency, then what will happen? It will be increased by 100 times. If I am taking 15 gigahertz frequency, it will be increased by 225 times. So 1 gigahertz to 10 gigahertz, power loss will be increased by 100 times. If 1 gigahertz to 15 gigahertz, only 15 gigahertz, so it will be increased by 225 times. So our loss of power, loss of energy will be occurs very fast. So at very high frequency, we cannot use transmission line. We have to use a better quality of transmission line, because there is a more loss of energy, and that loss of energy will generate more loss of heat. So I will not use high frequency transmission line. I will not use high frequency transmission line. Okay. So high frequency I will not use in the transmission line, because if it is increased, then what will happen? Then what will happen? If it is increased, it will happen like this, our loss in the transmission line will increase. So this is happening here, and we cannot use high frequency. So loss due to inertia cannot be minimized. Loss due to free electrons can be minimized by taking perfect dielectric, and loss due to conductor can be minimized by taking perfect conductor. So lossless transmission line can be made by choosing perfect conductor and perfect dielectric. Okay, but perfect conductor is very costly, so I will use good conductor. So there will be some loss. Okay, there will be some loss. Then after there is this one is a transmission line, yes sir, and this one is a transmission line, and there is a conductor inside it. You have seen the coaxial transmission line in your life, that this is the conductor inside it. Where you have seen in your cable, or in your TV connection, you have seen that this type of transmission line you have seen. So which type of transmission line you are seeing? Which type of transmission line you are seeing? This type of transmission line. This is our transmission line which you see. This is our transmission line which you see. This one is our conductor, and this one is our dielectric. So for conductor, and then after dielectric, and then after conductor. This type of cable is used in your television, or in your network, or in your internet connection. If you are using Hathway internet connection, this type of network, this type of cable is used. So this is our cable used for our internet connection, or in our TV cable. So this is our central conductor. After that there is a dielectric. After that there is a conductor. So in topmost there is also conductor. in topmost there is also conductor which is net type, So it is made up of two types of thing, conductor, and in between them is dielectric. So conductor, and in between them is dielectric. So you can say that top conductor, second conductor, and in between them dielectrics are present. Okay, then what we are going to say, then so conductor is distributed along the transmission line. Conductor is distributed along the transmission line, and dielectric is distributed in between the transmission line, along the transmission line, and dielectric is distributed in between the transmission line. And dielectric is distributed in between the transmission line. In between the transmission line. So like that. So this is our conductor and in between the transmission line. So what will happening here? What is happening here? The conductor will be distributed along the transmission line. What is happening here? The conductor will be distributed along the transmission line, and the dielectric will be distributed in between the transmission line, like that. So if between the transmission line there is a dielectric, and along the transmission line it is a conductor. So you can see here also like this. There is a sheet of dielectric conductor and there is a sheet of conductor. So these two types of sheets are used, above metal sheet, below metal sheet, and in between metal sheet there is a conductor. In between metal sheet there is a conductor. So conductor will be placed like this. In between this metal sheet there is a conductor, dielectric. So this one is conductor, and below one is conductor. This one is also conductor, but in between them is dielectric. Okay, so dielectric is distributed in between the transmission line and conductor is distributed along the transmission line. Conductor has two things, that it has series. So I think along the transmission line is called as series, yes sir, or in between the transmission line is called as parallel. And we know that due to conductor there is two types of losses, one conductor loss and dusra second storage of energy in terms of magnetic field. So there is a resistance and there is a inductor. So inductor is due to conductor loss, and inductor is due to resistance is due to conductor loss. Inductor is due to storage of magnetic field. Why? Because in conductor current will be flowing. If current is flowing, then there is a storage of magnetic field. If there is a current, there is a magnetic field. If there is a magnetic field, the magnetic field will be replaced by L. The conductor loss will be replaced by R, and the magnetic field will be replaced by L. Why there is a magnetic field? Because there is a conductor, and in conductor there is a current, and that current will be replaced by, that current will give you the magnetic field, and that magnetic field will be associated with inductor. So I think you have understand. Then after in dielectric what will happen? In dielectric there is a loss which is represented by G, and the dielectric, because of dielectric there is a capacitor, because we know that capacitor is made up of dielectric. So there is a capacitance due to dielectric. So conductor is along the transmission line, so resistance is along the transmission line, inductance is along the transmission line, conductance is in between the transmission line. Capacitance is in between the transmission line. So in between, that means in between, so it will be in between, so it is parallel combination. If it is along, it will be how it will be series condition. So R and L will be in series and G and C will be in parallel condition. So I will tell you that these four things, two things I will write here and two things I will write somewhere. Next page. So today we will complete basic. Then after we are going to discuss what we are going to discuss. So this one is resistance. And this one is conductance. Resistance will be decided by R, conductance will be decided by G. Okay. First one is, it is due to loss of, due to conductor loss. Why it is defined? Why we have taken? In taking we are counter out due to conductor loss. So due to conductor loss, I am taking this into the counter. Second thing is, it is distributed along the transmission line. It is distributed along the transmission line. So along the transmission line. Transmission line. Third thing, it is due to, it is in series condition. It is in series condition. So resistance will be in series condition. It gives attenuation because it gives loss, so it gives attenuation. In which part? Voltage part. Why? I will tell you. It gives attenuation in voltage. Why it is giving attenuation in voltage? I will tell you. Okay, I will tell you after some time. Then after, so I will tell you here also, dV by di, dV by dz, so dVx upon dx, dVx upon dx, so it will be minus times, it will be R plus j omega L Ix. Okay, this is the transmission line equation. You can derive this equation, but I am using this to understand the concept. So what is the concept here? dV by dx R plus j omega L Ix. I will derive this condition, but right now I am using this. So here change in voltage, change in the real part of the voltage. Real part of the voltage is given by R, and imaginary part of the voltage is given by L. So L will give imaginary part of voltage change and R will give real part of the voltage change. Voltage change is negative, so it will be decreasing, and since it is decreasing, so we are giving attenuation terms. If it is increasing, we are giving gain terms, but here voltage is decreasing with the distance, so I am saying that it is a attenuation terms. So change in the voltage is a real part, means attenuation will be given by resistance, and phase shift in the voltage, there will be phase shift, there will be attenuation, there will be phase shift, and the phase shift will be given by inductance. So we can say here from this equation. Okay, then after we can say for like this, we can say for conductance also. We can say this concept like this, the concept like this for conductance also. What is, in case of conductance, it is due to dielectric loss. In case of conductance, it is due to dielectric loss. Understand? So, in case of conductance, it is due to dielectric loss. It is distributed along the transmission line? No, in between the transmission line. So, it is due to dielectric loss. Okay, and it is distributed in between the transmission line. In between the transmission line. And it is in between, so it is in parallel condition. It is in parallel condition. And it gives attenuation in current, because in parallel condition current will change. In parallel condition current will change, so it gives attenuation in current. So change in current will be given as G plus J omega C into Vx. Yes, sir. So in series, voltage can be changed, so voltage attenuation will be performed. In parallel, current will be changed, so current attenuation. So current attenuation will be given by G, current's phase shift will be given by C. Okay, so this is the point here regarding resistance and conductance. Again we have inductor, inductance. Again we have inductance and capacitance. So we have inductance. Inductance is due to storage of magnetic field. Capacitance is due to storage of electric field. Capacitance is due to storage of electric field. Yes, sir. So storage of magnetic field, storage of electric field. Storage of magnetic field and storage of electric field. Okay, it is distributed along the transmission line, so it is in series condition. It is distributed along the in between the transmission line, so parallel condition. It gives phase shift. It gives phase shift. So phase shift in voltage is provided by inductance. So phase shift in the voltage is provided by inductance. Phase shift in the current is provided by capacitance. So it gives phase shift in current. Phase shift in current. Okay. So this is for inductor and capacitance. So there is a 4 parameters in the transmission line: resistance due to conductor loss, conductance due to dielectric loss, inductance due to storage of magnetic field, capacitance due to storage of electric field. Resistance and inductance is due to conductor, and inductance, capacitance and electric field, capacitance and conductance is due to dielectric. Conductor is along the transmission line, so resistance and inductor is along the transmission line. Dielectric is in between the transmission line, so conductance and capacitance are in between the transmission line. So we can say that R and L is due to conductor, R and L due to conductor, yes sir, and conductor is along the transmission line, so R and L will be also along the transmission line. Series condition, transmission line, that means series condition. Why it is in series? You can see that. G and C will be due to dielectric, and dielectric is in between the transmission line. In between the transmission line. So in between the transmission line is parallel. In between the transmission line is parallel. Parallel. Next is our conductance, reluctance, and next is our RLGC, So R and L will be in series condition. So R and L will be is series condition, resistance and inductance. Capacitance and G will be in parallel condition. Capacitance and G will be in parallel condition. So they are in series condition, they are in parallel condition. There is three types of network. First one is L network, second one is T network, third one is pi network. So there is three types of network. So transmission line will be replaced by these three types of network: L network, T network and pi network. So there is a transmission line, there is a transmission line, here it is a transmission line, here it is a transmission line. Yes sir. And this transmission line has a small area, a small length, that is delta x length. Delta x length. The RL and GC is given in distributed parameter. That means it is present all over the transmission line. G is present all over the transmission line. C is present all over the transmission line. And L is present all over the transmission line. That means, what I am going to say, that means this is the transmission line. Yes sir. So this transmission line is have distributed everywhere. That means at this point there is a conductor, there is a dielectric. So due to conductor R and L, due to dielectric G and C. So this small part, this small, little bit small part, that will be replaced by your RLGC network, so that we can analyze through mathematically. So by mathematical equation, by how we can analyze? By this small section of transmission line will be replaced by network. Then we can analyze. So this transmission line has everywhere resistance, this transmission line have everywhere capacitance, this transmission line have everywhere conductance, this transmission line has everywhere inductance. That means capacitance, inductance, resistance, conductance is distributed all over the transmission line. ये पूरे ट्रांसमिशन लाइन में कैपेसिटेंस और इंडक्टेंस कंडक्टेंस डिस्ट्रीब्यूटेड है. That means we can say that this is the point here, that this all transmission line we have to analyze through network. So what we will do, we will take a small section of, there is a small section of that transmission line part, and by which we will replace RLGC network, and after that we will say everything. So what we are doing, we are doing just that, this small section of network, this small section of transmission line will be replaced by three types of network. First is T network, second is pi network, third is our L network. So there is a network, this one is L network, this one is L network. So how it is, we can say that this one is G into delta x. Why? It is per meter. So G into delta x, C into delta x capacitance, L into delta x inductance, and R into delta x resistance. So why I am multiplying delta x? Because this delta x size is replaced by a network. This delta x size will be replaced by a network. Then there is a T network also. So what we will do, I will take in two parts, I will divide this R and L in two parts. So in two parts what it will be? In two parts what it will be? So in two parts, this one is R, yes sir, this one is L. So it is divided in two parts, so Rx by 2, L delta x by 2. So since it is divided by in two parts, so since it is divided in two parts, it will be R into delta x by 2, and this one is L into delta x by 2. This one is R into delta x by 2, and this one is L into delta x by 2. Yes sir. This one is G into delta x, this one is C into delta x. Yes sir. So there is a T network. Then after there is a pi network. Then after there is a pi network. What it will be the pi network? The resistance and inductance will be same. The resistance and inductance will be same. So R into delta x and L into delta x. Yes sir. And there is conductance and there is capacitance. Yes sir. So conductance and capacitance. This one is which type of network? This one is series type of network. So this series R up into delta x, R into delta x by 2, R into delta x, L into delta x, L into delta x by 2, that will be L into delta x. So R by 2, R by 2, R, L by 2, L by 2, L. Like that you can say that, there is G by 2, G into delta x by 2, because in parallel condition conductance will be added and in parallel condition capacitance will be added. So G into delta x by 2, G into delta x by 2 and C into delta x by 2. So G into delta x by 2 and G into delta x by 2, G into delta x and C into delta x by 2, C into delta x by 2, it will be C into delta x. Actually there is a only 12 to 15 hours, 16 hours class. So in 16 hours class I cannot complete coordinate system and vector calculus because it will be very big topic, 30 to 40 hours class, Ankur. But so I have decided that I will discuss transmission line theory class in a crystal clear manner, in a crisp manner, so that you will understand everything. If you have studied, you can understand. If you are college going student, you can understand, and then after we will discuss the question, so that you will get revision, or if you want to get knowledge for college examination, so it will help you a lot and on that period. So during college examination it will be help, during GATE preparation examination it will be help. So I have decided to take this topic only, because vector calculus and coordinate system it will be very tough, and I am not going to teach entire EMFT here because there is a less time available in my slot. Okay, for EMFT you have to require 100 to 120 hours on YouTube. So 100 to 120 hours it is required, but right now we don't have that much time, so I am just teaching the crash course type. Okay, I have taught EMFT on Hindi channel, that means get Wallah ECE electrical channel, ECE electrical channel, and you can search by name Sonulal Gupta Electromagnetic Field Theory. You will get 50 lectures of electromagnetic field theory, and some topic I have left, and that topic will be covered in fast track course of EMFT by Sonulal Gupta. So fast track course of EMFT by Sonulal Gupta, you will follow that course, and the course of crash course of EMFT. Then for Hindi batch going student, you can complete full electromagnetic field theory. Okay, so then we are going to start, I am going to start what? The derivation part. This derivation part is important for which purpose? Is important for college going student. So L into delta x. So if you are college going student, you want to give examination, so you will give the examination, or you will give the paper, or you will solve this question like this. So they will ask derive wave equation in transmission line, you will derive like this. Okay, so this is our delta x section. So this length is x is equal to x, and this length is x is equal to x plus delta x, means this point it is x plus delta x, and at this point it is x only. At this point it is x only. So what is the length of this section? Delta x. What is the length of this section? Delta x. Okay. So there is a voltage drop here which is Vx into T, and there is a current which is Ixt. After traveling delta x, the current will be changed. So at this distance the current will be changed. How much it will be? Ix plus delta x into T. And at this distance the voltage will be changed. That means V into x plus delta x into T. Yes sir. So there is a voltage, there is a current, there is a voltage, there is a current. So after that what we will do? After that we will apply KVL, KCL, and you will get the answer. Okay, we will apply KVL, KCL, and we will get the answer. So what will happen after that? Okay, so I will ask that what I will ask? I'll ask that what is the voltage drop here? So I into R, voltage drop, L di by dt, current, voltage drop, and here current is C dV by dt. Yes sir, current in the capacitor, and current in the conductance is, it will be V by G. So V into G, V by R, that means V into G. So we have current in this case. So what is the voltage drop across resistor? Voltage drop across resistor is I into R. I is Ix comma T into R. Voltage across inductor is L di by dt. L di by dt. So L di by dt, di by dt is dou Ixt upon dou T, because there is two variables, so I will use dou T. There is two variables, so I will use dou T. Okay. So our voltage drop will be, what it will be? And I know that, what I know that current and voltage is time harmonic. Current and voltage is time harmonic, so it will be j omega t. So I will write it down, j omega L. If I will differentiate, what will happen? J omega L into delta x, and differentiation will be same variable, so Ixt. So if I will differentiate with respect to time, it will be j omega L. So we have derived the equation for VR and VL. Then what we will do? What is the voltage drop? Here voltage drop Vxt. Here voltage drop Vx plus delta xt. So we know the voltage drop here. So this minus this is equal to this by using KVL. So V minus Vx minus Vx plus delta x is equal to voltage across RL. So voltage across RL is Vx comma T minus Vx plus delta x comma T. So this is voltage across RL. So this is voltage across VR, this is voltage across L, and this is voltage across RL. So VRL is equal to VR plus VL. No, this is for electronics engineering. You can go for electrical engineering. It is very helpful for power system. So you can study basic of transmission line. It is very helpful for power system also, because you use this formula for power system also. Then we have what we have? So then we have voltage across RL is this voltage plus this voltage. So V into I R into delta x, R into delta x, Ix comma t, yes sir, plus L into delta x, something like this, yes sir. So I x comma t, I x comma t, I will take common, R into delta x plus j omega L into delta x, j omega L into delta x. So this is voltage across RL. This minus this, voltage across RL. This plus this, voltage across RL. So I am equating this. After that, I know that with respect to t, it is harmonic, e to the power j omega t. So I will write Vx e to the power j omega t and Vx plus delta x e to the power j omega t. Yes. Then after Ix e to the power j omega t and R into delta x plus j omega L into delta x. Why it is? Because it is time harmonic. So for time harmonic, it will be replaced by e to the power j omega t. Time harmonic. E to the power j omega t will be cancel out. So we have Vx minus V of x delta x, and I will derive with respect to delta x. So it will be R plus j omega L into Ix. Yes sir. I will take limit delta x tends to 0. I will take limit delta x tends to 0. If delta x tends to 0, what will happen? There is no change in this side, there is change in this side. What will happen? Vx plus h minus Vx divided by h, it will be dV by dH. So it will be written as minus dV by dH dx R plus j omega L into Ix, R plus j omega L into Ix. So this is our equation for voltage. So how we have derived this? So there is a concept here, you may know that Fx plus h divided by h, limit h tends to 0, what it will be? Df by dx, df by dx. You should know this point, you should know this point. This is इलेक्ट्रॉनिक्स इलेक्ट्रिकल दोनों के लिए बाबू, आप दोनों के लिए पढ़ सकते हो, द बॉस आप दोनों के लिए पढ़ सकते हो। बस इसमें यही है कि आप इलेक्ट्रिकल वाले, ये इंग्लिश में है तो मुझे इंग्लिश में पढ़ाना है, आई हैव टू टीच इन इंग्लिश। इफ वांट टू स्टडी इन हिंदी यू कैन गो थ्रू द क्रैश कोर्स एंड फास्ट ट्रैक कोर्स। बाय स्टडिंग क्रैश कोर्स और फास्ट ट्रैक कोर्स आपको स्टडी करके आप EMFT कंप्लीट कर सकते हो, अगर यूट्यूब से कंप्लीट करना चाहते हो। I don't have any idea GATE DA guide is coming in the market or not, because there is no such exam, it is a new exam, so there may be some question setter, they can make question like that so that you will give the exam। तो ऐसा हो सकता है कोई सेटर बनाए, आप क्वेश्चन अब सेट करने वाले के ऊपर डिपेंड करता है, क्योंकि अभी वो एग्ज़ाम नया है, ठीक है। सो वोल्टेज अक्रॉस R इज I into R, वोल्टेज अक्रॉस L इज L di by dt, voltage across RL is this plus this. It is time harmonic with time, so it will be replaced by e to the power j omega t. If I will differentiate e to the power j omega t, so it will be j omega and it will be same as it is, so j omega as it is. So we know that after that voltage across RL is Vxt minus this is voltage across RL. So voltage across RL is Vx minus Vx plus delta x. So Vx minus Vx plus delta x, and voltage across RL in terms of R and L will be like this. Then after what I have done, we know that it is time harmonic, e to the power j omega t, e to the power j omega t, because of time harmonic. time will be cancelled out. So we have delta x, that delta x I will divide it here, and after that I have written. We know that this delta x side will be very small, this delta x size will be very small, so very small, so I will take delta x tends to 0. As we know that fx plus h minus fx, what it will be? So as we know that I will write it here. You know that you have studied in 12th class also, that fx plus h minus fx divided by h, limit h tends to 0, what it will be? df by dx, df by dx. You have studied. So like that we have derived fx plus h minus fx divided by h. So I will take minus common, so minus dv by dx, so minus dv by dx, like that it will be. So this is the derivation. Then after current, I will take current. So what is the current? What is the current through G? Current through G is V by R, but R is G, so V into G. So current through G is Ig, through G is V by R, so V plus x delta x comma t divided by R. R is not G into delta x, so G into delta x. And current in capacitor C dV by dt, so dou Vx plus delta x comma t divided by dou t. As we know that Vx plus delta x comma t will be written as Vx plus delta x comma t e to the power j omega t. Then I will ask dou Vx plus delta x comma t divided by dou t, it will be written as j omega Vx plus delta x e to the power j omega t. That means j omega V x plus delta x comma t. Okay, so I will replace through j omega, so j omega c into delta x V x plus delta x comma t. Okay, so this is our current in conductance, this is our current in capacitance, and then after we have voltage. So we know that after that applying KCL at this node, current is Ix comma t, yes sir, and current is leaving this much, so current through this one is IGC is how much? IGC is this minus this is equal to this, so I x comma t plus IGC plus Ix plus delta x comma t, yes sir. So Ix minus xt minus Ix plus delta x comma t is equal to how much? IGC? Ig plus IC, so Vx plus delta x comma t and R into delta x plus j omega c into delta x, yes sir. As we know that it is time harmonic, so Ix e to the power j omega t, Ix plus delta x e to the power j omega t, and after that Vx plus delta x e to the power j omega t and R into delta x plus j omega c into delta x. So e to the power j omega t will be cancel out. So what we will have minus Ix plus delta x minus Ix divided by delta x is equal to Vx plus delta x and R plus j omega c, sorry, G plus j omega c, this one is G plus j omega c. So this one is G plus j omega c, G plus j omega c. So I will apply limit delta x tends to 0. What will happen? If I will apply delta x tends to 0, this one is differential form and this one is Vx. So we have minus dix upon dx, dix upon dx is equal to Vx G plus j omega x c, G plus j omega c. So this is our voltage, current. This is our current. So we have derived current, we have derived voltage, everything we have derived. So this derivation is asked 20 marks derivation in your BTech exam. After that, Vx comma t. So we have derived what we have derived. First one is derived d Vx divided by dx is equal to r plus j omega l into ix, and second one we have derived dix upon dx G plus j omega c into Vx. So we have derived. So from this equation what we have decided? From this equation change in voltage will be decided by, so change in voltage, attenuation in voltage is decided by R, and phase shift in voltage is decided by L. Surely like that, in current attenuation is decided by, G, and phase shift will be decided by C, like that. This equation is also known as traveling wave equation. This equation is known as traveling wave equation. So equation is known as traveling wave equation. Okay, and R plus j omega L is nothing but Z, and G plus j omega C is nothing but Y. This is known as series. This is known as series impedance. What it is known as? Series impedance. And Y is known as shunt. Due to parallel condition, shunt admittance. Unit of R is ohm per meter. Unit of G is Simon per meter. So unit of Z is ohm per meter, and unit of Y is Simon per meter, or Simon is 1 by ohm per meter, or per ohm per meter, or mho per meter, or you can write it like this, inverse of ohm per meter, because Simon is 1 by ohm, 1 by ohm is per ohm, or ohm opposite is mho, and ohm opposite is like this. So it will be written as like this. So our Simon will be written as like this. Simon will be written as like this. So there is many method to represent Simon. There is many method to represent Simon. Okay. After that, we will derive traveling wave equation. So in tomorrow class, we will derive traveling wave equation, and we have derived traveling wave equation, and then after we will go through the lossless and distortionless transmission line. So VP, VG, lossless and distortionless transmission line, everything we are going to discuss in the next class. So next class is lossless and distortionless transmission line. After that class we will discuss, so on Monday we will discuss something like this. After that we will discuss the questions, something like that, lossless and distortionless transmission line. So every topic will be completed and question will be discussed. Every topic will be completed and question will be discussed. I will give summary also. So after every teaching I will give summary, so that you will get good question, yeah, or you will get good concept regarding that. Okay, so I will give summary also. So summary, after summary you will get the everything. So what we have studied, some basic part, basic, that means conductor loss, dielectric loss. Second, we have is decided parameters, transmission line parameters, transmission line parameters. So Monday class will be transmission line parameters. And third is traveling wave equation, traveling wave equation. So we have derived traveling wave equation also. Thank you for today class. Tomorrow on Monday we will discuss everything. What is the utility? Unity is something is given by the PW. It is interactive poles. In this we have get poles, 3D model library, live class notes and doubts, YouTube notification, dashboard leadership and video call. So you can take utility pw.live login, and so that you can log in and register yourself. It is a very good point, you can go through that. It is a very good app. Thank you everyone. We will meet it again. Thank you.